Today we're going to talk about the probability distribution. We're going to go over this example. It says in the carnival game under or over 7, a pair of fair dice is rolled once, and the resulting sum determines whether the player wins or loses his or her bet. For example, the player can bet $1 that the sum will be under 7, that is 2, 3, 4, 5, or 6. For this bet, the player wins $1 if the result is under 7 and loses $1 if the outcome equals or is greater than 7. The player can bet $1 that the sum will be over 7, that is 8, 9, 10, 11, or 12. Here the player wins $1 if the result is over 7 but loses $1 if the result is 7 or under. A third method of play is to bet $1 on the outcome 7. For this bet, the player wins $4 if the result of the roll is 7 and loses $1 otherwise. So we're going to construct a probability distribution table representing the different outcomes that are possible for a $1 bet on under 7. So, get a pen out. So I'm going to make a table. It's going to be a small table because we're only looking at what happens if you bet $1. So you can either win or you can lose. If you win, you're up $1. And if you lose, you're down $1. Okay? So let's figure out the probability that you are up $1. In order for you to be up $1 on the under 7, let me go back. It says the sum has to be 2, 3, 4, 5, or 6. So if we look at this table, this is the table that has all of your sums. So the way this table works is that you have one die here, and I'll write it out so you guys can understand it. This is die 1, this is die 2. Okay, so you roll die 1, you roll die 2. You get a 1 on die 1, you get a 1 on die 2. You add them together, you get 2. Make sense? If you get a 2 on the first die and a 3 on the second die, you add them together, you got a total of 5. So this is what this table is. It represents all of the sums. So in order for you to get to win $1, you have to be under 7. So what you're going to do is you're going to count all of the outcomes that are under 7. Here we have a total of 36 outcomes. If you count all these numbers inside here, we have a total of 36. So I'm going to put 36 here. Now I'm going to count all the numbers that are above 7. And when you count them all up, you should get 15. Alright, so now you'll lose $1 if you are, I believe it says 7 and over. So you're going to count all the outcomes that are 7 and over. So let's see. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if you get over 7 and above, if you get 7 and above, you lose. And there's 36 ways that you, 21 ways that you can get 7 and above. So it's 21 out of 36. And in this problem, you cannot reduce. Well, actually, you can reduce because 3 goes into both of these. So let's reduce these. So 3 times 5 will give you 15. 3 times 12 will give you 36. So the 3's cancel out. So you have 5 over 12 for the first one. And here, for the second one, it would be 3 times 7 all over 3 times 12. So it'll be 7 over 12. So let me we draw the table so you guys can see it better. You can be up $1. That's supposed to be a plus. I'm not good at drawing. Or you can lose $1. And you have 5 over 12 here. You have 7 over 12 here. Alright. So all I did was reduce the fractions. So let's go on to the next one. We're going to construct a probability distribution representing the different outcomes that are possible for a $1 bet over 7. So you can win $1 if you get an outcome of 7, over 7. So I believe they said 8, 9, 10, 11, and 12. Is that what it said, over 7? 8, 9, 10, 11, or 12. So what you have to do is go through and count all the numbers that are over 7. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it'll be 15 over 36. And remember we said that reduced to 5 over 12. And then you can lose $1 if it's under 7, 7 and under. So in this case, it'll be 21 out of 36 again. And we said that reduced to 7 over 12. Okay, so it's just like the last problem that we did. This is supposed to be a fraction bar. Sorry, can't do it. This is what I'm trying to do. There we go. All right. So now let's go to the next part. We're going to construct the probability distribution representing the different outcomes that are possible for a $1 bet on 7. So that means we want to get exactly 7. Either we get 7 or we don't get 7. So if we get 7, exactly 7, we win $4. Alright, so on a $1 bet, I'm up $4. So we got to figure out all the ways we can get 7. And it's 1, 2, 3, 4, 5, 6. 6 different ways that you can get 7, exactly 7. 6 out of 36, or you can just say 1 6. And if we don't get a 7, that means we're down $1. We lose $1. And it's 30 ways that you can not get a 7. If you count all the numbers besides 7, it should be 30 outcomes. It'll be 30 out of 36. And that is going to reduce to 5, 6. Okay. So now the next thing we're going to do is we're going to figure out the expected value. What is the expected win or loss in the long run? So the expected value is calculated. This is what you call your mean. Expected value is the same as the mean. This is a summation bar, and you're going to take x and you're going to multiply it by the probability. So if we look at under 7, if I drew the probability table again, we can be up $1 or we can lose $1. The probability that we're up $1, we said was 15 over 36. And the probability that we're down $1 is 21 over 36. You can use those reduced fractions if you want to. I don't have it on my paper, so I'm just going to use what I did originally. I didn't reduce originally. So to figure out the expected value of that, You're going to take the plus $1 and times it by its probability of 15 over 36. And then you're going to add the next one, which is negative 1 times its probability of 21 over 36. So when I get my answer, this is a plus, sorry. When you multiply it out, you get 15 over 36 minus 21 over 36. And then when you do the calculations, 15 minus 21 is negative 6 over 36. And then when you divide it out, you get this answer. So in the long run, you're going to lose. You're going to lose since it's a negative. It's going to lose 0.167 cents. Okay, so you're going to do that for over 7 and on 7. And you should get the same answers for all three. All right. Hope this helps.